The nitriding process has been used for over 100 years. Elements that undergo nitriding gain higher abrasive resistance and hardness. The lifetime of such elements is significantly extended. Sometimes nitrided engine elements may work much longer than the very engine. In the nitriding process, steel elements absorb nitrogen like a sponge. In the furnace, nitrogen reacts with steel and diffuses into it, creating nitrides, which add hardness to steel. The ability to control the process is the matter of the last 3 decades. It was possible due to the introduction of the computer as the major element which controls the process. The ability to control the nitriding process is the biggest challenge in this industry, therefore it is a niche market. We have visited one of the world leaders, Nitrex Metal, which produces gas nitriding systems. At the plant in Sosnowiec, the work on the production of the furnace starts from the design stage. The diameter of such furnaces is from 40 to 160 centimeters and its depth is from 1 up to 5 meters. Although furnaces may be larger, everything depends on the client's order. The main elements of the furnace are the shell, the insulation, the cover, the heating elements and the retort. A retort is the furnace interior which contains the rack with the load which undergoes nitriding. Therefore, the retort is constantly exposed to the atmosphere and it needs to be made of a super-resistant material so as to ensure its durability. Such a resistant alloy is Inconel 600, which consists of nickel, over 70%, and chromium, 18%. After a dozen processes, normal steel turns into powder. The assembly of the furnace starts from the shell, which is a steel cylinder separating the retort from the outside. Inside the shell, several layers of insulation are installed so as to stop heat from escaping from the furnace interior. The next step is placing the retort in the furnace shell. This is an extremely difficult moment. The retort weighs approximately 1.5 tons. The retort needs to be lowered in a safe manner so as not to damage the insulation inside the shell nor the heating elements which are situated on the walls at a distance of 100 mm from the retort. Therefore, the retort assembly is a delicate operation. It is also important to be careful not to damage the thermocouples. After installing the retort, the cover is mounted. This is the place where the hoses, in which processed gases are transported, valves, which control the atmosphere, and the motor of the atmosphere mixer are installed. The mixer generates an extremely strong wind, which ensures atmosphere uniformity throughout the furnace. The gas panel is extremely important as it enables the precise control of the processed gases composition. The control of the process inside the furnace is provided by the computer. It is the most important element of the whole system. The computer controls the 3 most important process parameters: temperature, chemical reactions and time when given elements undergo nitriding. The gases that leave the furnace during the nitriding process are directed to the exhaust gas neutralizer. Here, exhaust gases are burned in the temperature of 950 degrees centigrade. Finally, let's focus on the work in the laboratory. In order to check the correct functioning of the furnace, it is necessary to examine the quality of the components that undergo nitriding. A fragment of the part that undergoes nitriding is extracted and examined under a microscope. This is aimed at measuring the thickness of the white layer on the surface of the object and the diffusion layer which absorbs the nitrogen. Also, the hardness profile is checked. If the nitriding comply with the most restrictive specifications, the furnace is ready for operations all around the world. Such furnaces are indispensable in the manufacturing industry, mainly the automotive and aerospace industries.